From our previous courses in programming, we simply define an algorithm as a finite set of instructions for the purpose of accomplishing a task or solving a problem. When we solve a programming problem, we first write or create an algorithm, right? Or draw a flowchart before starting to write a program, which is the algorithm implemented using a programming language. Since the program or software program is based on the underlying algorithm, it is important that we make sure that the algorithm we create as a solution to the programming problem is efficient or effective. So this time, let's take a closer look at algorithms. Let's check what are the 5 important properties of algorithms. So first is finiteness. This means that an algorithm must terminate after a finite number of steps. Now recall, in our programming course, we discussed that there are 2 types of algorithm, okay? And what are those? Do you still remember? What are those 2 types? First is the partial algorithm, and the second is total algorithm, okay? Recall that partial algorithms are those algorithms whose programs are intended to run 24/7, like those online, airline ticketing, or airline seat reservation, or online shopping like Lazada, Shopee, right? They run 24/7, so that anytime you would like to buy a ticket or shop online, then you can do that. While the second, which we call as total algorithm, these are the algorithms that has a definite start and a definite end. So most of our programs, the underlying algorithms are total algorithms, okay? We run it, so there is a definite start, and then after a while, it stops and gives us some output or results. The second is definiteness. It means that the algorithm is clear. The instructions of the algorithm are clear. They're precisely defined. Say, for example, if the algorithm has an instruction which is divide by a number x, it is not clear, right? So what is clear is that you would say divide by a positive number x. Okay? So in that way, you are certain that, or you are precise that x is a positive integer, not just any number, but a positive integer. So again, the instructions must be precisely defined. That is what we mean by definiteness. The third property is input. Input of a program or algorithm are also called the domain of the algorithm. Okay, these are the raw input data. And every algorithm or program could have 0 or more inputs. Okay, so it means that your algorithm or your program may have 0 or no input. Okay, so an algorithm or program may have no input, 0 input. But for output, what is the requirement? There must be at least 1 output. Okay, so output is the set of 1 or more resulting quantities, which is also called the range of the algorithm. So input of the algorithm or program is called domain of the algorithm, while output of the program or algorithm is called range of the algorithm. Now, does it sound familiar, these 2 terms, domain and range? Now, recall in mathematics, when you call f a function, and then you say let y be f of x. Okay, this is a common notation in mathematics. So if f is a function in terms of x, we call x the domain, right? The domain of the function f. And we call y the range of the function f. So if we let f, the function in mathematics, to represent our algorithm, then the input to this algorithm f is x, which is called the domain. Okay, that's why we call the input of the algorithm as domain of the algorithm, while y is the range of the algorithm f. Okay, because we represent an algorithm by f. So when we input this domain x, value x, into this algorithm, it gives us an output result, which is the corresponding y for that input. When we input another value, then we have another unique output y for that input value. Now, again, for input, how many inputs are required for an algorithm or program? It could be 0 or more. So it is possible for an algorithm or program to have no input, but it is required that there must be at least one output. Now, what do you think if an algorithm has no output? Is that a useful algorithm? I don't think so, right? So that is why it says here that for an algorithm, there must be at least one output, because that algorithm is useless if it has no output. Okay, so there must be at least one output. And the fifth one, the fifth property is effectiveness. This means that we ensure that all the operations in the algorithm are sufficiently basic so that in principle it can be done. The instructions or the operations can be done exactly and in finite time, not infinite but in finite time. So there is a definite start and a definite end. It can be done by a person using paper and pen. So an algorithm is effective if the operations or all the instructions, all the calculations of that algorithm can be performed by a human or a person using paper and pen. Do you think it is valid when we say that these calculations of the program or the software, it cannot really be carried out or done by a human? It is impossible. Do you think that is a valid statement? Now, basing on this fifth property, it is not valid, okay? The operations and the calculations involved in that algorithm must be sufficiently basic so that there is a human that can carry them out manually using paper and pen. It's like when everything is already computerized, and then what will happen if there is a power interruption? You cannot use the computer. So what will you do? You will shut down your business. You will close the store because everything is computerized and you cannot do the business transaction manually. So there must be a backup or an option to be able to do manually all the operations. Now remember that for every programming problem, you could solve it in many ways, right? So say we have here one programming problem. It is possible to solve this, or this can be solved in several ways, right? So one programmer could come up with one algorithm, another programmer who thinks in a different way, who have a different preference. So he has also, or she has also, a unique algorithm to solve that one problem, okay? Or another programmer could solve it in another way, okay? So say for example, we have 3 programmers solving only one programming problem. One programmer comes up with algorithm A1 as the solution of that problem. Another programmer come up with an algorithm or a program 2 solving the same problem, and another programmer came up with an algorithm or a solution A3 for that same programming problem. Okay, maybe this has 5 variables, and then it has 10 instructions or statements, and then maybe this second algorithm makes use of 7 variables, and this has 8 statements. Okay, and maybe this has 3 variables only and 5 statements to be executed. Okay, now this is possible, right? So it is possible for only one programming problem to be solved in several ways. So you have several solutions, okay? Say for example, in this case, we have 3 solutions or 3 algorithms. Solution number 1 is algorithm 1, solution number 2 is algorithm 2, and solution number 3 is algorithm 3. That is why the term is complexity of algorithm. This refers to that situation. Why complex? Why is there a complexity of algorithm? Because, as I've said, one programming problem can be solved in many ways. It is possible to solve it in many ways. And therefore, the complexity is how are we going to select the best algorithm, or what are the criteria? What are the factors we are going to consider to be able to select or choose the best algorithm to solve that one particular programming problem? Okay, the complexity now is which of these 3 solutions, A1, algorithm 1, algorithm 2, or algorithm 3, should we select as our best solution for that one problem? What are our criteria to select the best algorithm among these 3 available solutions? Thus, the term complexity of algorithm. Now, since in our example, we're able to come up with 3 algorithms as solutions to this problem, it is important for us to analyze the algorithms so that we could select the best solution among the available algorithms solution. And knowing how to measure the efficiency of algorithms helps a lot in the analysis process. So the question now is, how are we going to choose the best, or what are the criteria to select the best algorithm among the available? What are these 2 factors or criteria to select the best algorithm or program? First is choose an algorithm that saves RAM or memory. Okay? Choose an algorithm or program that saves memory space. So, if the algorithm or the program makes use only of fewer variables, then it saves RAM, right? Because every variable you declare or use in your program, that is allocated memory space. And so the lesser the variables there are in the program, the lesser the memory space are consumed by the program or allocated to the program. So if there are more variables, then there are more memory locations that were allocated to that program or algorithm. The second is choose an algorithm that saves running time or executes fast or runs fast. And what would affect the running time of an algorithm? It is the number of instructions to be executed. The more instructions there are to be executed, the longer the running time of the program. Because there are many instructions to be executed, then the longer it would take to end the program and obtain the result, right? So among these three algorithms, algorithm A1, A2, and A3, which do you think is the best algorithm based on these two criteria? A1, A2, or A3? I hope your answer is A3, right? This has three variables compared to A1 and A2, which have 5 and 7. So fewer variables means it saves RAM or memory space. And then this has 5 statements to be executed. This has 8 and this has 10. So the program implementation of this algorithm A3 will execute or run fast because this has only 5 statements to be executed while this one has 8 and this one has 10. So the best algorithm is A3 based on our criteria. So how are we going to measure the efficiency of an algorithm, or what are the two criteria to measure the algorithm efficiency? As mentioned already last time, what are the two criteria to select the best algorithm among many available algorithms? They are, what are these two? Again, saves memory or RAM and runs fast. So we have here a term called space utilization that refers to this one, saves RAM, right? Space utilization refers to how much RAM or memory space is used by the algorithm or program, okay? So the lesser the memory space used by the program or algorithm, the better. Okay, it saves RAM or memory space. And the second is time efficiency. Okay, that refers to the second criteria here, meaning it runs fast. Okay, so time efficiency refers to how fast an algorithm or program runs or executes. So again, space utilization is the amount of memory required to store the algorithms or programs data, while time efficiency, or referring to the performance of the algorithm or program, is the amount of time required to process the data of the program to be able to obtain the expected results or outputs. Now, before we could measure time efficiency of an algorithm or program, we need to compute the running time or the execution time. Okay, what is execution time or running time of an algorithm or program? It is simply the amount of time spent in executing the instructions of an algorithm or program. And it is dependent on the particular hardware specifications of the computer being used. Now, we express this execution time or running time as a function, t of n. That's the notation, where t is the time function and n is the size of the algorithm's input. Now, in our time function, t of n, recall that n is the input size. From our time function notation, we could say that the input size of the algorithm determines the running time of the program. But in reality, there are actually 5 factors that affect the execution or running time of an algorithm or program. The primary one is the input size, okay? But there are still other factors, okay? And these are the second is underlying algorithm, the machine speed or the computer's hardware, the speed of the processor of the computer being used, and number 4 is the quality of source code of the algorithm implementation or the program, okay? Because it is possible that the algorithm is implemented using different programming languages, right? You could implement the algorithm in C language, for example, or in Java, or in Python, or in COBOL or Fortran or any other high-level programming languages. And each of these programming language has unique properties or execution characteristics. Okay, so they are not the same. The running time of the C program, the Java program, the Python program, and the COBOL program of this one algorithm is not the same. The running time of all of these programs, which are implementations of that one algorithm, the running time are not, of course, the same. Okay, so again, the running time or execution time of a program is dependent also on the programming language you use to implement the algorithm. Thus, we say that the quality of source code implementation of the algorithm is a factor. The last one, or the fifth one, is the quality of the machine code generated from the source code by the compiler. Now, recall in our earlier programming course, the source code is compiled first, and then resulting object code is further compiled or interpreted or translated until we have the true executable code. Okay? The file with the .exe is generated. That is the file of the true executable code, which is equivalent to the source code. Okay. Now, the one that is running is not the source code, but it is true, the true executable code, which is in the form of binary, right? Ones and zeros. One program can be compiled using different compilers, right? So for example, this is a C program and you compile it using dev C++, then the resulting code runs in a unique way compared to the resulting code compiled by, say for example, Code Blocks. Okay, this is another compiler, C compiler. Okay, this has running time 1, running time 2, and maybe if you use Turbo C version 7 compiler, this would generate another code with a unique running time, say R3. Okay, so different compilers generate different codes. And since these are different codes, they have different execution time as well. Let's take, for example, a sorting algorithm. Say, for example, in this sorting algorithm, the input to the algorithm n is the number of integers to be sorted. Okay? Say, for example, n is equal to 5. You input 5 as the value of n, and then you proceed to input these 5 integers. So say, for example, they are 2, 10, 1, 3, and say 5. 1, 2, 3, 4, 5 integers to be sorted. Say for example, the input is in that order. First, in the 5 integers is 2, and then next is 10, third is 1, and then fourth is 3, and the fifth is 5. Okay? So that same sorting algorithm, this time maybe at time t1, sorts 5 integers, which are this. And the result, of course, is 1, 2, 3, 5, and 10. Okay? Say another instance, at time t2, you run this program again, or this underlying algorithm is being run again. And say, for example, on the second run or execution, you input n equal to 30. So you're going to input 30 integers to be sorted. Okay, say for example, 2, 10, 1, 3, 5, negative 4, then 11, 23, and then and so on. 30 integers. Okay, there are 30 integers to be sorted. Now, do you think that the running time of the program at time t1 at this instance is the same as when you run it again, having 30 integers now to be sorted? Obviously, the answer is no, right? That same program will have different running times, okay? So the running time of that program would be longer when it is going to sort 30 integers compared to when it sorts only 5 integers, okay? So it would take a long time to sort 30 integers than to sort 5 integers, okay? That's a very obvious conclusion. And so we could say that indeed the input size to an algorithm or program will determine how long it takes to run the algorithm or the program. The smaller the input, the shorter the running time. The higher or the more inputs, the longer the running time, right? So fewer inputs, shorter running time. More inputs, longer running time. Okay, because there are many inputs to process, so the running time is longer.